Now we are going to see 7 segment display interface, that is how to connect the 7 segment display with 8085 microprocessor. Uh, you might be knowing what is a 7 segment display is. This is a diagram of the 7 segment display, that is you will have 8 LEDs arranged as a 8. Each LED has given the name AB as designated by letter A, B, C, D, E, F, G, and you also have one more LED that represents the decimal point. Actually, you will have 7 A, B, C, D, E, F, G, that is 7 segments. Here the LED is arranged in 7 segments in the form of 8. So it has been given the name 7 segment display, and you have one more segment which is called as a decimal pointer, which separates each letter or character, we can say. Using the 7 segment display, you can display any number between 0 to 9 as well as A to alphabets can also be displayed using this 7 segment display. The display that is there in your microprocessor kit, you would have seen the display in the microprocessor kit, what you have done in your practicals, that is 7 segment display. You have two types of 7 segment display. One is common anode type, other one is common cathode type. As I told, it is nothing, just a LED arranged in a 7 segments, that is a 7 segment display. The common anode is, you all know that LED has two terminals, one is anode, other one is cathode. Here in common anode type, all the anode terminal, that is all the 7 LEDs anode terminals are connected together and is given to supply. And if you want to lit any particular LED, then you have to apply, that is anode always will be given to supply and cathode has to be connected to ground represents 0 volt. So when you want to display any of the segment, you have to give 0 volt to this particular letters, that is segments we will call. Then you have common cathode type, where cathodes are connected together and connected to ground, whereas anode is left free. Whichever LED you want to glow, that particular segment has to be given a data. For example, let me draw this 7 segment display. This is a 7 segment LEDs arranged in a 7 segment form, that is in the form of 8, and it is given, each LED is given the letter, it is designated by the letter A, B, C, D, E, F and G. Okay, suppose I want to display 2. 2 means A, the segment A, segment B, segment G, segment E and segment D has to be lit. So if I use common anode, then 0 volt has to be applied to A, B, C, not C, A, B, G, then E and D. Remaining segments will be given a high voltage. Same way in common cathode, suppose I am using a common cathode type, then whatever the segments I have mentioned before, those segments has to be given plus 5 volt, or other segment has to be given 0 volt. Always a 7 segment display requires a driver. So driver IC is 7447. It is called as BCD to 7 segment decoder. It has 4 inputs and 7 outputs. The 4 inputs are given the letter capital A, capital B, capital C and capital D, and the output of this is designated as small a to small g as mentioned in the 7 segment display. Here, according to the input that you give at the lines A, B, C, D, it will be converted to the 7 segment code. For example, if this code is given, I think for common cathode. Common cathode is not common cathode, is common cathode, that is, let me go back. The cathode is, this is the cathode. The cathodes are connected together and connected to ground. Whichever LED you want to lit, that segment has to be given 1. So this here the 7447, that is BCD to 7 segment decoder. Its name is BCD to 7 segment decoder. It is connected to the 7 segment display. See, if you want to display 0, if you want to display 0, then A, B, C, D, E, F has to be given high voltage and G alone has to be given low voltage. So, when I give the input as 0, 0, 0, automatically the output will be decoded. If I want to display 4, then the input for this 7447 should be 0100. This is what you will give. Automatically, it will give the corresponding code to display 4. This is the block description of the 7 segment display. It shows how it is connected to 8085 microprocessor. You all know that you cannot connect 8085 microprocessor directly with the any applications. Instead, you have to use the 8255 ports. Here we have used two ports. One is port A, other one is port B. Both are used as an output port. Port A is connected to the decoder 7447, which is BCD to 7 segment decoder. Here they have used 4 7 segment displays. The output of the 7447 is connected to 4 7 segment displays. Here, since we are using 4 7 segment display, it is connected parallelly with the 7447, and whatever the data that is output to 7447, suppose if I want to display 2, then let me go back. What is the code to display 2? 0010. So we have to give the data 0010 to the lines capital A, capital B, capital C and capital D of 7447. Automatically, the 7447 IC will generate the code to display 2. The code is 11011101. So that code will be available at the lines small a to small g. Since the 4 7 segment displays are connected parallelly, this data will be available to 4 7 segment displays. Suppose I want to display 2 in all the 4 7 segment displays, then the bottom part is not required. The bottom part is not required at all. So once you give the data, immediately the data for 2 will be available at the lines A to G, and all the 4 7 segment display will display the letter 2. Suppose I want to display like when I give first data, then it has to be displayed at this line at the this first 7 segment display. The next digit has to be displayed on the second 7 segment display. The next digit has to be displayed in the third 7 segment display, and the fourth digit has to be displayed in the fourth 7 segment display. In that case, the bottom part is required. That is, here I have used one more port, that is port B, where you have connected 4 transistor. Whichever 7 data will be parallelly available to all the 7 segment display girls. Okay, but here with the help of this transistor, we are activating only one 7 segment display by giving the corresponding data at the output port. Suppose I want to like the application is you want to display 0 to 9. Using this 4 7 segment display, 0 has to be displayed in this first 7 segment display, 1 at the second 7 segment display, 2 at the third 7 segment display and 3 at the fourth 7 segment display, and it has to go back. 5 at the again first 7 segment display, 6 at the next 7 segment display, and so on. In that case, first you will give the data to display 0 at the line ABCD. It will be converted to the required code for this 7 segment display code and will be given to all the 4 7 segment display. But using this output port B, you will select only one 7 segment display, that is first one alone. So the data 1 will be given to the first transistor alone. Remaining transistor will be given with the data 0. So the digit 0 will be displayed in the first 7 segment display. Then what will happen? You will be providing the data to display 1 at the line ABCD. That is BCD code. The BCD will be converted to the 7 segment code, and it's again given to all the 4 7 segment display. Now you will provide the data to activate only the second 7 segment display. So you will give the code at the port B is 0100, so on. Okay, now let me see the program. Since I'm using both the ports as output port, the control word is 80. So first we are moving that control word 80 to accumulator. Then the control word is sent to the control register, that is out CR. Then we are initializing a register with 09. That show this initialization part shows that we are going to display the digits 0 to 9. So the register C is initialized with the number 9. Now the register B will carry the BCD value. So the BCD value is stored in B register. Then D register is used to select the 7 segment display. First we are giving 01. 01 means only the first 7 segment display will be selected. Then we are moving that BCD code to accumulator. This BCD is connected to port A. So we are outing that BCD code to out port A. Then the transistor is connected to port B. So the transistor code is given as 01 in D register. So from D register we are moving to accumulator, then out port B. After doing that, we are rotating the accumulator. What you are rotating? Initially D is having the data 01 which is moved to accumulator. 01 means when you decode that into binary, it is 0000 to 0001. Okay. When you rotate, what will happen is this 1 will go to the next position. So the value become 0, 0010. So that the next transistor can be selected. So rotating, then we are moving to the D register. So now the code is ready to select the next 7 segment display. Then increment B. Why we are incrementing the B? First the B register is carrying the data to display 0. Now it is incremented to 1. Decrementing C. C is nothing, a counter. Counter that is counting whether the digits 0 to 9 is displayed. So we are decrementing the C, then checking whether the C has reached 0. No in the case, go back to loop. Going back to the loop is from the B register, the data is moved to accumulator. Then we are sending the data to port A. Then D register data is moved to accumulator, out port B. Then it is rotated again. When it's rotated again, this one will occupy the next position. So the using the third transistor will be activated, and the third 7 segment display will be selected. At the third 7 segment display, the digit 2 will be displayed. So on. So this is your program. Thank you.